Okay, so this video is going to show you a couple more examples of some things that may help you with your homework in section 1-4. You might be asked in your homework to find constraints that will guarantee continuity. So here's a function. The problem area is at 3. That's where the possible discontinuity is. Okay, so we want to figure out what A would have to be in order for it to be continuous at 3. Okay. So in order for it to be continuous at 3, as x approaches 3 from the right, okay, when we're approaching from the right, that was when x is greater than 3, we would use ax squared minus 1. So the limit of that, if we plug in 3 for x, that's going to be 9a minus 1, okay? And if we find the limit as x approaches 3 from the left, we're going to use this part of our function, ax plus 1, because that is when we're coming from the left, when x is less than 3. That is going to end up looking like 3a plus 1. Now, in order for this to be continuous at 3, these two limits from the left and right have to equal each other so that there is a limit. So if I set 9a minus 1 equal to 3a plus 1 and solve this equation, I will get 2 equals 6a, so a equals 1/3, okay? So if a is 1/3, we're pretty sure we're going to have continuity at 3, okay? Just to be safe, we're going to check some things. First of all, I'm going to check and make sure there is a value at 3 when a is 1/3. So we would have to use this one, so 1/3 x plus 1. So I'm going to plug in 3 for my x. So 1/3 times 3 plus 1, I get 2. Okay, 2 is the value. Now in order for it to be continuous at 3, my limit has to be at 2 as well. Okay, so I'm going to just kind of work off this. And I'm going to, if this number right here were 1/3, okay, this were 1/3, all right, the limit would be 2, because this is 3 minus 1. If a were 1/3 and a were 1/3, when we were finding the limit from the left, okay, we would have 1 plus 1, which happens to be 2. So there we go. We've got the limit is 2 and the value is at 2 when a is 1/3. The other thing I want you to look at in this section is called the intermediate value theorem, okay? And it's on your sheet if you want to look at the formal definition, but I'm just going to explain it with an example, and I think it'll make a lot more sense. Okay, so we're going to use this theorem to show that the polynomial function f of x has a 0 on the interval 0, 1. Okay, so to use this theorem, this is what you would do. You would first plug in 0 into your function. Okay, so I'm going to plug in f of 0, and I get 0 plus 0 minus 1. Okay, so this equals -1, all right? And f of 1 is 1 cubed plus 2 times 1 minus 1. So that is equal to 2. Now what this means is, let's just think about this. I'm going to sketch a little graph over here. That means, so we're looking at between 0 and 1. So here's 0. So with the function is at -1 when I'm at 0. And when I get to 1, here's 1, I'm at 2, okay? Now this is what the intermediate value theorem says. If it's continuous, and this is what it says on your sheet, if f is continuous on the closed interval AB, so if f is continuous on 0, 1, and k is any number in between 0 and 1, and k is any number in between f of a and f of b, which is basically this point and this point, okay, there is at least one number c in AB such that f of c equals k. So what it's saying is, if I want to show that there has to be a 0, if this function is continuous, let me use a different color, there is no way, this is a continuous function, so I can draw lots of continuous functions. Could look like that, could look like this, could look like this, okay? It could look a lot of different ways, But if the function is continuous, could maybe look like this. No matter what it is, if it's continuous, I've got to cross this x. I have to cross y equals 0. I have to cross 0 at some point to get there. Okay, there's no way I can get there if I don't cross 0. And that's what the intermediate value theorem is telling you. There has to be a 0 between 0 and 1, because if I have a point here on my function and a point here on my function, there's no way for me to get to from A to B without crossing 0. And that's all that means. So that's something that will kind of pop up here and there, and we'll talk more about it when we start looking at AP problems. But that's all it's trying to say. If the function is continuous between A and B, okay, there has to be a point in there somewhere where it crosses 0 in this particular case, okay? And that's it.